So in the previous videos, we have completed up to the one of the main topics, that is mean precipitation. So three different methods we have seen in the mean precipitation calculation. The first one is arithmetic mean method, then Thousand polygon method, and the last one is the isohedral method. So we have also seen what are the differences between these three methods and which is the best method among these three. The third one, isohedral method. Okay. Now in this chapter or in this video, we are going to see the next important topic, which is very important numerical point of view. Okay, so let's start. The heading of the topic is frequency analysis and risk analysis. So this is the heading of today's concept that we are going to discuss. Okay, now for getting into the details of what is risk analysis and frequency analysis, first we should understand that what is the importance of measuring the precipitation or recording the precipitation values. So now what we'll do, I will not be saying precipitation now, I will be saying rainfall so that it will be more clear to you for understanding point of view. So let's say for the previous 5 years we have got a data. So from 2015, I will start 2015, 16, 17, 18 and 19. So these 5 years data we have of precipitation. So precipitation or rainfall values we have here from 2015 to 2019. So if I write the values, let's say I am taking the arbitrary values here. So this is 10 centimeter, 11 centimeter, 13 centimeter, 15 centimeter and 11 centimeter. Okay, so these are the values of precipitation in the previous 5 years. So let's change it somewhat so that it will be looking more practical and all values will be different. Okay, so now we have all the values different here. Okay, so these are the values of precipitation. Now what is the importance of these values? See, this precipitation, it is related to design of many hydraulic structures. So what will happen if more rainfall will occur? The more the rainfall, the more will be the discharge in river. We have seen in the initial classes that this catchment area, okay, in the catchment area, all the small streams they connect to a major river. Okay, whatever the rainfall is taking place in the catchment, due to the slope, it meets with the nearby streams, small streams, and all streams meet one major river here. Okay, and then this river, or we can say the discharge in the river increases the Q value. So indirectly, we can say that the rainfall is related to the water in the river or the discharge in the river. Okay, now we all know that the dams are built on these rivers. Okay, what is the purpose of dam? There are many purposes, but for now we'll just stick to one rule, that is it is used to store the water. Okay, and when the water is needed, at that time it is released. So for construction of this dam, for the construction of this dam, there should be some certain amount of rainfall for which we will have to design it, or we can say for how much volume of water it can store. That volume capacity will depend upon the amount of water that will come through this river. And what is the amount of water that will come in this river? It will depend on what? It will depend on the precipitation. So we can say that the amount of rainfall or this rainfall, it influences the discharges in a river. Correct? If more the rainfall, more the discharge in the river. And this discharge in river, it is used for the design of design of dams, or we can say design of hydraulic structures. I hope you are getting a basic idea what is the main use of this collection of the data. Okay, So that means, let's say that now we have only taken the previous 5 years data. If we take the previous 100 years data, okay, so we will get some maximum value of precipitation. Let's say the maximum value of precipitation was 20 centimeter. Now if we design the dam for 20 centimeter rainfall, then the probability that this 20 centimeter rainfall will not be exceeded, that means there will not be more than 20 centimeter rainfall, it is relevant. Okay, or we can say there is maximum probability. Even if you see in this 5 readings, if I design the dam for 20 centimeter rainfall, okay, so even if there is the highest rainfall, that is, let's say in 2018 it was the highest rainfall 15 centimeter, then also our structure is safe. Okay, so what we are studying now, this is called as a risk analysis. Okay, so we are analyzing what is the risk. Okay, so this is a basics of risk analysis. Now we will have to find out what is the probability that in the coming years this 20 centimeter rainfall will be exceeded. Now why we have to calculate the probability? Because these hydraulic structures which we are seeing, if we take the example of dam, then these are very costly structures. Okay, crores of rupees, thousands of crores of rupees are invested in this construction of dam. So we have to make sure that the dam is not breached or overflowed. The dam should be working for maximum number of years. Okay, so we have to take care of that. So during the design process, we have to design it for the greater amount, or we can say the greater capacity. This is decided by using the frequency analysis and risk analysis. So this is all the basics that was required. Okay, now exam point of view, what is the important thing that we have to understand? So we will have to find out the probabilities of, let's say, I have given it to you that 20 centimeter rainfall we have to design it. Okay, for 20 centimeter rainfall we have to design a particular hydraulic structure. So what is the probability that the 20 centimeter rainfall will be exceeded? Okay, so let's start writing slowly one by one, you will understand it. So give the heading first, frequency analysis. Frequency analysis. Okay, so frequency analysis, it is done on random event. Frequency analysis is performed on a random event. Okay, now what is the meaning of random event? See, if you just take a coin, okay, let's say we both are playing head and tails by using a coin, and you are betting on heads and I am betting on tails. So 4 times I am flipping the coin. In all the 4 times it is getting the tails. Okay, but is it necessary that on the fifth time also it will be tails only? No, that means the outcome of, and that outcome of the event is random. Everything is random. We cannot say it do not depends on anything. It is completely a random event. So to analyze these random events, okay, see, this rainfall is also a random event. We cannot say that next year the rainfall will be more or less. It is a completely random event. However, we can analyze, however we can, by using certain analysis, we can give the answer in terms of probability, that there is 80% probability that this rainfall can be exceeded. Okay, in terms of coin we can say that there is 50% probability that there will be tails if there is heads in the previous one. Okay, so such thing is called as the frequency analysis, and it is performed on the random events. Okay, now this rainfall and floods will obviously, it will occur after rainfall only. So rainfall and floods, these are random events. Now the probability p of rainfall, probability p of rainfall at position m, at position M being equal or exceeded is called as probability of exceedance. Probability of exceedance. Okay, so from now on, if there is a term like this, probability of exceedance, that means what is the probability that the rainfall at the position M is equal or exceeded. See, what is the meaning of this? Let's take this example only. As I have told you, in previous 100 years, the maximum rainfall was 20 centimeter. Okay, now if we want to find out what is the probability that this 20 centimeter rainfall will be exceeded, then we have to arrange this data which we have arranged here. We don't have to arrange it as in terms of the years, we have to arrange it in terms of decreasing order of rainfall. So right now, instead of this 20 centimeter, what we'll do, we'll remove this 20 centimeter and we will keep 15 centimeter. Okay, because 15 centimeter is present in our data and it is the highest rainfall. So what we'll do, we will arrange this data in the descending order. So which is the highest one? 15 centimeter. Then next is 13, then 11, 10 and 9 centimeter. So what is this? This is the decreasing order. This decreasing order in this frequency analysis is called as annual series. What is the meaning of annual series? We'll write it down. Right now you just understand it. Annual series means we have to arrange the data in the descending order. Now we have to give the markings here. So the first marking is 1 value, then 2, 3, 4 and 5. Okay, so these markings, this order is called as the M value. Okay, now see in this formula you can see the probability P of a rainfall at position M being equal or exceeded is called as probability of exceedance. I hope it is clear. So if I say what is the probability of 15 centimeter rainfall being exceeded, then you have to take the value of M in the formula. Okay, what is the value of M in this case for 15 centimeter? 1. Okay, let's go on to the next one. So to find out this probability, we will be using the following formulas. So the first formula is given by V bull, and the formula is P is equal to M divided by N plus 1. Then the second formula is given by California, and this is P is equal to M divided by N. And the last formula it is given by Hazen, and it is M minus 0.5 by N. Okay, now here M, we know that what is the M here. Okay, now what is the value, what is the meaning of capital N? So this capital N is number allotted to last position, So in our data, what is the number which is allotted to the last position? It is 5. Okay, now if in the question it is asked what is the probability that 15 centimeter rainfall is exceeded, then you have to take the value of M is equal to 1, N is equal to 5 and substitute in any of these formulas. So in the question it will be given that use the Weibull formula, use the Hazen's formula, use the California formula. So you read the question properly and then use the required formula. Okay, so this was about the probability. Now the next concept is about the return period. Okay, return period. So return period T, it is calculated as 1 by probability P. So we have seen the probability formula here P. If we just make inverse of it, that is 1 by P, it will give us the return period. Now what is the meaning of return period? This value will come in years. So let's say if it is 1 year, it is 1 year. That means for the particular probability, after 1 year, the same rainfall will get repeated. Okay, so if we take this example, in this example, let's say we are taking the value of 15 centimeter here. So for 15 centimeter, first we will find out the value of P by using, let's say first we are using the California formula. So what is California formula? M divided by N. So according to California, it is M divided by N. So for 15 centimeter rainfall to be repeated, what is the value of M? 1. What is the value of N? It is 5. So 1 by 5, it is 0.2. Correct? That means there is the value of P is 0.2 or 20% probability. That there is 20% probability that this 15 centimeter rainfall will get, it will occur after this next year. Okay. Now what is the recurrence period? After how many years this 15 centimeter rainfall can occur? So we can calculate it as 1 by P. 1 by P means 5 divided by 1, that is 5. So after 5 years again, this can repeat. Okay, this 15 centimeter rainfall can repeat. So this is the value of return period. Okay, so see, once we will solve problems from this, then it will be more clear. Right now just get a basic conceptual understanding. Okay, so we'll just write down the procedure. So in the procedure, first step is arrange the data in annual series. Annual series means descending order. Okay, then assign rank to each value starting from 1 to n. Okay, then use formula to find P and T. Okay, so P is the probability of exceedance. One thing you have to note here, that this P plus Q, this is equal to 1. See, this P means probability of occurrence of an event. PQ means probability of not occurrence of an event. So this P plus Q will be equal to 1. So we can also write it as this Q is, it is equal to 1 minus P. Okay, this Q, it is equal to 1 minus P. In the coming formulas, that is in risk analysis, we will be using this. We will be needed this. Okay, so hence I have given it to you here. So this is the basic one, probability of occurrence of an event and probability of non-occurrence of an event. So the combined probability, it is equal to 1. Okay, so this is all about the frequency analysis. Now we will start the next one, that is risk analysis. Risk analysis. So in the risk analysis, we have to only see the formulas here. So one by one we'll write down the formula. The first formula that you should know is probability of occurring an event r times in n successive years. Okay, so in the coming n years, what is the probability that the event will be occurring r times? So to calculate this probability, we'll be using the binomial distribution. So according to that, the probability P, it is equal to NCR into p to the power r to q to the power n minus r. So this will give us the probability that an event is repeated or occurred r times in n successive years. Now second one, what is the probability of not occurring an event in n successive years? See, probability that an event is not occurring in n successive year, that means in this case the r value is equal to 0. So in the first formula you substitute the r value is equal to 0, so we'll get the probability is equal to nc0, that is 1, p to the power 0, that is 1, so you will get q to the power n minus 0, so q to the power n. So the probability here that that event is not occurring in n successive year, it is equal to q to the power n. See this q, it can also be written as 1 minus p to the power n. And how to calculate p? This p can be calculated by these three formulas: Weibull formula, California, and Hazen. Okay. So the last one, risk, it is equal to probability of an event occurring at least once in n successive years. And this risk, it is equal to probability of not occurring an event was q to the power n, so at least occurring once will be equal to 1 minus q to the power n. So this can also be written as 1 minus p to the power n. Okay, so on these three formulas only all the questions will be asked, so learn these formulas properly. And one more, just write it down: what is the amount of safety or the percentage safety is equal to 1 minus risk. Okay, or we can say if it is in percentage, then 100 minus percentage risk. So this will give us the safety of structure, percentage safety. So these are all the formulas from the risk analysis. Okay, the risk analysis is completely dependent on the frequency analysis. Once we get the probability, based on the probability of accidents, we can find out all the values. Okay, so that's it with this frequency analysis and risk analysis. When we will solve the problems, we will get more clarity on this.